For this project, an old CD drive was dismantled for the shaft in the design of the DC motor. The shaft is about 3 mm in diameter. This shaft will be the backbone of this motor. Here with the basic materials used to build the DC motor. The aerosol cans are used for motor lamination sheets built into the armature of the motor. A critical point in the design is to ensure the lamination angles are cut all correct. Use steel aerosol can and not aluminium. Aluminium is a very low magnetic permeability. In this process, you must ensure that all lamination discs are insulated from each other. This is an important part of the process to reduce eddy currents. Special steel is normally used in the construction of a stator and is called electrical steel or silicon electrical steel. Use type epoxy to insulate the lamination discs from each other. This is the process of assembling the lamination pairs to form one solid stack that will be the core part of the rotor. This is the rough finished product of the assembled laminations and the basic shape of the rotor. The rotor is taking shape and prepared for the next step in the construction of the DC motor. The center hole is drilled to accommodate shaft. Precision drilling is required. Epoxy glue is used to secure shaft to rotor. Make sure measurements are correct for drive end and non-drive end. Positioning is critical for the commutator. The basic material used for commutator segments are copper. For 3-pole DC motor, the commutator are fitted with 3 segments for coil connections. Commutator segments are now in place with marking guides for wounding the coils to the correct positions. Coated wire is now wound onto the armature and the start and end of coils are soldered to the commutator. Pay attention to the turns of wire per coil and the direction. Soldering must be checked for dry joint. The motor housing is now prepared to accommodate the armature and brushes. This all must be aligned properly and in a straight line for smooth operation and running effect.
Okay, this is to determine the north and the south of the magnet. As you can see, the bar magnet is marked N, and I've marked already an N on this magnet just to make sure it's the north magnet. We're going to push the north to the north. As you can see, it's pushing away. I'm going to turn the bar magnet around for the south pole, and it should now attract. And this is how we determine the north and the south of the magnet.
The mounting of the brushes and the position of the stator magnets are fitted. This will interact with the rotor coils, which will form the electromagnets in generating the magnetic forces for attraction and repulsion, which rotates the rotor in the direction of the force. Proof of Australian 20-cent coin as weight in demonstration.
This is project ENG174 with the electrical motor in the front and the battery source at the back. The motor is on a height of 1,100 millimeters, and it needs to be lifted up to 1 meter height, which is now inside there. You will see a red string on the side of the measuring tape leading all the way down to the floor, where you will find a 20-cent coin attached to it. There's the 20-cent coin, and as soon as we start the motor, it needs to start lifting it up all the way up to the 1 meter mark, which will coming up now. There's the 1 meter mark, and then we've got that 110 up to there.
Wow! Wow!
This is proof of the 20-cent Australian coin and the poster I've made on my theory.